So a rough agenda of what we're going to go through. We have the ProPanel manufacturing. This is a recap of the manufacturing advantages you can get out of ProPanel. We're going to have a look at the panel cutouts, drilling patterns. We'll have a look at the din and trunking cutout lists that you can generate, wire numbers and extractions of them to go to a wire printer, number printer. We're going to look at the wire connection points and wire routing. And this is all part of the wire routing at the bottom here. Then we're going to look at the new features that have been added to ProPanel, including the PLC Bus Extension, SLDs, single line diagrams, 2D panel layouts are now available in there. We're going to look at some model space cross-references. We're going to look at the new view changes and savings of views. We'll look at the wiring manager that's been added, and that's an extension of the routing, the wire routing. And then we'll look at the copper bending to finish. This isn't a new thing, it's been added in freely, but it's something that I think is highly underutilized. And finally, we'll have a quick look at smart production, and there's something awesome that comes along with that with ProPanel 2026. So let's start by having a look at some ProPanel 2026 manufacturing and the time-saving advantages that you can get out of this. Having a look at the traditional OEM panel production, and this is kind of something I used to do in industry, where you have a job and you plan it all and you order all your parts, but you can't really start working on that panel until the order arrives, the panel's delivered, your wire's delivered, and everything's ready to go. And from that point, you're starting flat-footed. Then you've got your marking and drilling of the gear, the mounting panel. And then you start on your measuring and cutting your din and duct rails to fit all the wires and the clip devices on. You mount the devices into the panel, and then finally you sit there with drums of wire and pull it off and label it and highlight a schematic and work through that as you go to wire everything. And this can involve a really methodic, stepwise production method, which takes, can take quite a bit of time. So the advantages we get out of ProPanel is that you're able to disjoint this and actually make some of these processes happen independently. So obviously at the start, you continue with your ordering of parts on your panel, but then as soon as that order's gone in, you can start by pre-cutting your din and duct, and this is because you've created a digital twin of the panel. And then you can start looking at cutting and labeling all your wires or outsourcing your wire production to arrive in bags ready to install straight away. And this can happen before you've even got the panel delivered. Once you have the panel delivered, you can use that digital twin to automate the panel machining. This means that you've already chosen all your holes and holes and threaded holes to mount everything up, and you can just put it into a machine, have it done very quickly, and go straight to mounting the pre-cut din and duct rails. You've got them set aside for that panel. They go straight in, screw in, and you're away. Then into mounting the components on, and finally installing prepped wires, which you can mark off, or using smart production, go through that. And by disjoining this and breaking up this process and adding the automation, you can drastically reduce the time between when you start the job and when it heads off to testing. So the big changes in ProPanel 2026. Originally, ProPanel 2025 was a standalone package, or with P8, you can get a ProPanel add-on. And then if you wanted the wire routing add-on, it would be an addition. If you wanted the copper bending add-on, that would be an addition, as well as there was no single line diagrams, there was no 2D panel layouts, and there was no PLC handling in this. From then, if you wanted to look at smart production, that was a 3-stage process as well, in terms of there was smart mounting, smart wiring, and the whole smart production suite. That has all been included and built into ProPanel 2026. So with your ProPanel 2026, it is slightly more expensive, but it does come with everything. It has the wire routing in it, it has the copper bending in it, it has one smart production suite seat, so you can have one smart production console running, and it has a new wire manager to help with the wire routing. So this is all now included in ProPanel 2026. So looking at those ProPanel manufacturing outputs and what you're really driving for is automating those cutouts and all your drilling patterns and cutting of the fan vents, etc., mounting for the isolators, um, coming up with your DIN and duct or your DIN rail and trunking lengths to pre-cut that ready to go to save time on the job. Having your wire extractions with your not just your wire numbers, but also the lengths of those wires so that they can be fully crimped, pre-assembled, ready to put straight into the panel or terminate straight into the panel. And then if you do go down the path of copper bending and bus bars, is having that all sorted, and that's disjoint as well, meaning that you can actually bend up your copper bars before your panel arrives and have it ready to install. And this is all brought about because of this 3D digital twinning of a panel. So first, just looking at the automated cutouts. The output types of the automated cutouts is a DXF file, which can go to a lot of industry laser or machining manufacturing machines to drill, tap, cut, route, etc. Or you can create a Perforex data file, which will go directly into the Perforex machine, and we have worked with a few of these. So it's neat and packs up, ready to go in a single file that we can send off. The outputs can be customized in terms of how you want your coloring done for what color do you want tapped holes, what color do you want drill holes, do you want text marked on it, do you not want text? So this can be completely customized, and you can have a machine profile saved. And we actually work with CSL and their Perforex machine, and we have a saved profile, and this profile can be saved, exported, and imported so that other people can use that machine straight away with a setup that we know works. We have the ability to auto-generate this from the layout space. So once you've actually placed all your DIN and duct in ProPanel, I'm not going to go through the placing of it today, but it's pretty much snap on a corner, drag it the length, and click again. It'll actually automatically place the drilling holes as per your drilling pattern. You can see it's even moved a few of them to dodge the holes in the mounting panel. And this will allow you to automatically generate your 2D drilling patterns and produce those outputs straight away. The drilling patterns are held in the parts. They're actually a saved drilling pattern that belongs to the part or can be used by multiple parts. And in the same way, parts can have multiple drilling patterns. So if you have two different ways you drill a trunking, depending on which customer it goes to, that can be done as well. And you can also manually add additional cutouts, holes, threaded holes, etc. as you need it, just by clicking and placing them straight onto the panel or onto other sides of the enclosure. And they're just exported through as you go through the file export machining, and then either this NC DXF or the laser Perforex or the BC Perforex. And cutouts of most shapes are totally possible. You can create polygons that you want to cut out. It's just down to a routing corner of about 3mm or 5mm, depending who you use to manufacture your cutouts. This is the Perforex itself, the Mighty Perforex. This is the exact one that they have at CSL. And what it can do is, I mean, to typically do a mounting panel used to take 8 hours of marking it up with a vivid and then start drilling and tapping it and breaking a few taps in the process. I've seen this thing do an entire panel enclosure in less than 25 minutes, and it takes no mistakes at all. Once it's done it, you can reproduce that panel every time perfectly, and it takes no coffee breaks. You can actually take a coffee break while it's producing your panel. So the automation of it's amazing. And if you have 10 of an enclosure to do, you can just mass run them through the machine. The DIN rail and trunking lengths, again, this comes directly from the layout space. Once you've placed your DIN and ducting, as long as I usually use a DT device tag prefix, like UB for bus bars, UD for DIN rail, and UT for trunking. And then I can filter based on that for a parts list, which I call a cutting list. And it actually gives the part number of that part, be a bus bar, DIN rail, or trunking, along with the DT in terms of where it's placed to match almost an enclosure legend for trunking and DIN rail, as well as the length that it needs to be cut at. Obviously, these need to be zero referenced to the holes, but once they're all cut, they can be put aside and ready to go. Custom drilling patterns are completely producible, and it's a complex way to create drilling patterns. We can help you out with that, but it's pretty much choose your first offset on the left, choose how many increments you want to skip and then increment size, and then it can generate, and it will auto move the end hole to make sure you don't get any funny drilling patterns right on the edge of din rail or right on the edge of trunking. And as I said, you can save multiple drilling patterns under one part and then have that part just choose which drilling pattern when you place it. This can be beneficial for something that's either mounted on its side or on its front, like a light ballast, for instance. So wire number exports, they can be exported using manufacturing extractions. That's again under the file manufacturing and then export labeling. Using that, you can export it to Excel. And from that Excel list, you can copy it to a template, or you can export it directly to the template if the template's in Excel, which will work with most label printers. We've, again, worked with CSL's label printer and had that running recently, no problem. But yeah, it'll work with other label printers, no problem. Brady label printers, you can copy from Excel, paste it in, and just run it via the PC. And you can also use this as debugging to check for missing labels or links. So you can run through all your connections in your panel, have a look and go, okay, that's missing a link, which means it hasn't been routed, or that one hasn't been, I haven't specified a size for that. And, it's going to get to the manufacturer and he'll be like, okay, what's that size going to be? So you can actually use it as a validity check before this goes out to manufacturing and save time and questions. So the next thing we're going to look at is wire routing. And this is now included freely in ProPanel. So it's a great thing to use. It's good to make advantage of it. And once you've got it set up and you're familiar with it, it becomes easier over time. And there's a great amount of reusability as well. So to start with, it can seem a little bit daunting, but in order to get the wire routing working, it's part of why we've got this webinar, so you can use this as a bit of a guide when we share it later. You've got the correlation between parts data and schematical drawings. I'll show you that shortly. I'll run through all of this shortly in a bit of a live demo, so you have a feeling for how to tackle it yourself or try it yourself. And we're always available for help if needed. Your devices require connection point designations. That's the actual point where the connection is made to. Your devices need to have connection point directions, and the direction is the vector to which the wire is coming in from, even though they usually point away from that connection point. Connections and schematics are required to have a name, color, and size to be able to be represented correctly in your 3D panel layout. And panels have to have routing paths to follow. And that can be a little bit hard to see, and you don't always need to add them when they're already placed by trunking. So we'll have a look at all this and see how it all works. To start with, let's have a quick look at parts data and schematics. So the connections needed to be defined in the part data under the functional template. So if you go under your parts management and you open up a part, under the functional templates for that part, you have a list of the functional points. This is a PLC box. You can see these PLC points are defined. It's actually for a VSD. A lot of people use PLCs to define VSDs, but it has a connection point designation and a connection point description. When this is represented in your schematic, you can inspect a device under your device inspector, and it will have a couple of different symbols. This white square represents something that's actually placed physically on your schematic. This blue triangle represents something that's actually defined in the functional template. So here we can see a circuit breaker's been defined in the functional template, but a triple circuit breaker has actually been placed in the schematic. This won't route. It won't understand this because it can't see that they're actually linked. If we look at this 20Q1 down here, we can see that it is actually linked. What we've got is we've got this blue triangle sitting on top of the white square. This is under your device inspector, remember? So here it's saying that the white square is, we've placed it correctly on the schematic, and the blue triangle says it's correctly defined in the functional templates. And because they're over the top of each other, it's saying ePlan can fully understand that they are linked. There is a connection between them. Next thing to look at just a quick mention is the data portal and data types. I think everyone that uses ePlan uses the data portal. I think there's getting close to 2.4 million, 2.5 million parts in there at the moment. It's incredible. But what you don't realize is that you can actually view the connection, the available data types for every part before you download it. And what you're really looking at here is for the production data types to be used with ProPanel and get that production automated is the connection point pattern, the 3D graphical data, which is the object placed in 3D space, as well as your drilling pattern, which is very nice because that means it's defined by the manufacturer and correct, including the connection point pattern. It's not something you really want to define every time manually. And it can come through from the manufacturer and you can place it straight into your panel and it's ready to use with the wire routing. So it can also affect, your part selection, or you can get parts and have your own company parts data set up correctly to have this data all valid and ready to go. That's the reusability. Talking about device connection points, what we've got here is you can view it under the view menu in your 3D space. On the left-hand side here, you can see it turns all the objects transparent when you click on it, and it places these red squares, these red cubes. These are actually the device connection points. Each one of these has an X, Y, and Z location, and it's saved similar to a drilling pattern in that it's saved as a connection point pattern. And a connection point pattern belongs to that part data. So every point in it, the connection definition, needs to match the functional template for the part. And this is how it creates that final link between knowing what's wired on the schematic, what's defined in the part, and where is it in 3D space. There's a few other properties associated with this. These include obviously the X, Y, and Z position from the origin of that part. There is a shortcut for placing these. You can actually just click on place connection point and click on the part. And there's also a routing direction. This is different to the routing vector. The routing direction is which way from the part it will search to try and find the closest routing path. I'll show you this and explain it in more detail soon. Finally, this X, Y, and Z vector is your routing vector. And this explains which direction the wire is coming out of that connection point. So in the bottom left here, we can see a PLC. It is connection point designations. And the wire is coming out of that vertically, either from the top or straight down from the bottom. On the right here, I believe we have some Phoenix contact terminals, and these are push-in terminals, but the wire actually comes out of the front of them. So ePlan ProPanel actually handles it to this level. It says this is the connection point, this is where the wire comes out in this direction, and then it knows exactly where it's going to search to try and find where to route that. Routing paths, again, as I said, can be a little bit confusing. They are automatically placed when you place down trunking. So by clicking on view, view routing path or routing path view, you can actually see the routing path. Sometimes it's a bit hard to see or a bit opaque, especially in 2026. So I click on fill capacity, which adds a little bit of an extra view, and you can see them quite clearly in here. And sometimes you're required to add your own. An example of that is this VSD that's been placed here. It's obviously needs to be routed. Its connection point designations are going to say route downwards to the nearest routing path downwards. So unless there is a connecting routing path across the bottom of it, it won't find anything to actually route to. So that's been manually put in. You can put in other features as well. Say if we had 5 VSDs, you'd run a line under the left 3 going left and the right 2 going right and leave a gap, in which case it will find the correct one to route left or right to the closest bit of trunking. So it's quite convenient that way. Again, sometimes you require additional routing paths put into 3D space. So on the top left here, you can see we've actually come out of the trunking and gone to the midpoint on the right wall, and then brought it forward on that right wall to actually handle wires coming forward to trunking on the back of the door to handle buttons or HDMIs. HMIs. On the bottom left here, what we've done is actually run from the trunking up the sides of the ceiling light, of the enclosure light, and it will know now that these connection point designations are actually set to route either right or left, and they will find this path and then route into the top of the trunking. So when you've completed routing, all your routing setups, it's simply a matter of clicking on device and clicking on this route button. And what it will do is it'll put in these lovely colored routes, as you can see here. And what it's tried to do is take into every context the routing vector, the routing path, and where it's routing to. These earth bars and neutral bar at the top here, you can see are routed upwards. This is twin set of contactors, and I've had to put a floating routing path between them to actually allow it to route to that path and then to the next contactor. And it's actually taking into account wire widths as well as wire colors here and represented it in the final 3D graphic. From that, you can generate your connection list, and you can see the list here with cross-section and color and the length of each wire. This is the whole principle, is to get this length and this table, which you can then export to a labeling machine or wire processing machine, which will automatically generate all your wire cuts, lengths, crimped, and labeled, good to go, and then wire straight into the final device. This is just an example of a wire routing terminal. This is Rotel's large machine here. This is an absolute beast. It handles everything independently. You give it your Excel list and it puts it all out just in a bundle wrapped up in a bit of tape. No manual handling required at all. In the bottom right here, we actually have it's a disjoint setup of a bunch of different individual machines, crimpers, devices cut to length, labelers, etc. But there's a number of different producers that have this similar kind of solution here. Wheel Mueller, finished contact, etc. All right, so let's jump into ProPanel and have a quick look at this. So I've got a basic panel here. If I was to go into my paper space and have a look at something simple, like this breaker, the way I would check the breaker immediately is going under its properties. I've got it here, Siemens breaker, opening it up and having a look under functional templates. So here it has a simple single symbol with connection points 1, 2, 3, 4, 5, 6. And that's how it's defined, no problem. So then what I would do is cancel back out of that. In my navigator for devices, device navigator, if you can't find this, it's under view, open, devices. I have one open all the time in here. Rather than manually finding it through the projects, I'd just right click and go synchronize selection. And it will find it here. And this one obviously is not happy. So it's saying that is not happy to be routed at this point. So that would require cleaning up. Whereas if I was to look at something, say like this power supply, and synchronize selection, what we can see here is everything is perfectly aligned. So every one of the device connection points is correctly defined. It has its white cube, meaning it's been placed on the page, and its blue triangle, meaning it has a correct functional designation. Under the parts data, try and go a bit slow here because there's a lot of data. Under properties, you have a connection point pattern right in the middle here. This is obviously the connection point pattern for this is defined exactly as the part, but this is similar to saving a drilling pattern or a manufacturer supplier in that it actually has properties and it has connection points. And these are the exact same connection points that are defined in the functional template. It has X, Y, and Z positions of it, and it has which direction it's being routed from, upwards from the part, downwards from the part, and it has the vector, X, Y, and Z vector 1 meaning upwards in the Y direction, -1 meaning downwards in the Y direction. So cancel. Right. So then if we were to look at this um, in the layout space, so graphic, that's in 2D placement, right? 3D placement right there. So that is the power supply there. What I was talking about earlier is if you go under view, you can say, show me the connection point designations, turns everything transparent, and zooming in, you can actually see these red cubes that are defined. There it's connection points, where it's actually wired to. From there, I can say, show me the connection point directions, and this is showing which way the wires are actually coming out of that connection point. So downwards. Over here, we've got a thermostat, etc. So you can get a feeling for how this all lays out. If I was to look at the larger enclosure, I've got the view turned on, but that's no problem. Turn around a bit. It is going to try and find those routing paths. So I'll turn those off for a little bit of graphic processing. I can look at routing path view and then fill capacity. And as you can see, it actually makes the trunking transparent here, and I can see these routing paths run in the panel. So it will route upwards from the top and downwards from the bottom to this connection. To route a device, let me just turn those off. I would simply click on it and then go to edit and then route. Bingo. And you can see here, it has to take into account the connection point designation of where it's going on the far end or alternative devices, such as these fuse terminals, which are fed vertically inwards. 2 different locations for the connection point designations on those, and they're routed upwards too. So it knows to come up into this duct and then back down through this routing path. At the bottom, you can see the connections from that are routed to one phase from the breaker and the other phase from the neutral bar. So that is wire routing, how to set it up and how to get it basically running. Let's have a look at the ProPanel 2026 new features. These are new features that have been made available, as well as existing features which have now been added to ProPanel. So to start with, we have the PLC Bus Extension. This is traditionally in P8, and I know quite a few people are familiar with using it. What it involves is you now have a PLC data navigator, which allows you to navigate your PLC setups. It allows for the generation of PLC reports, like PLC overview, which we find is in high demand. We generate that for nearly every project we do. It has PLC imports, exports of PLC data directly to some manufacturing types, which can go straight into the integrator's software. So that's quite handy as well, and something you can set up with your integrator depending on which PLC you use. And it has the ability to auto-generate some schematics. I think Phil covered this last week and showed you a quick sample of that. It now has the ability in ProPanel to generate single-line drawings. It's a simple thing, but wasn't available in ProPanel. It's now available in all ProPanel. So obviously just single line down the bottom here. Each single connection is representing 3 phases or single phase L1, L2, L3, etc. Just kind of overview single lines, very common diagrams, but they're now available. 2D panel layouts are now available as well. So this is the final step in that you no longer require any features from P8. If you have ProPanel, it is P8++. It has P8 plus everything else that was existing in P8. You can do your 2D panel layouts in ProPanel if you have a ProPanel license, ProPanel package, and not need to have to go to the 3D level if you've not allowed time for it, or if it's not going to save you time in manufacturing, or if you don't have those manufacturing options available to you. So there's no limit on what you can do now. Obviously, the under navigators, you can see the 2D panel layout navigator. You can actually use the 2D panel layout navigator to check off devices as you place them in your 2D panel layouts. It's got mounting panel layouts just like P8, and it can generate enclosure legends from those, and you can cross-reference and jump back and forward from them as well. So now ProPanel has model view cross-references. This is a new feature, something that's only been added in 2026. And what it allows you to do is, if you have a 3D part like our power supply, which you can see in the background here, it actually has a link or a cross-reference to every model space that's the 2D representations of the 3D model. It has it as a link, which means you can jump through every layout space where it has that power supply. So if you make a change in the 3D and you want to know which one of your layout spaces to update, you can use that to jump back and forward. And this was a new feature to me, is the Alt page up and page down to step through the cross references for a device, but very useful, and it's good because you can go straight from the part to the model view of the layouts. Finally, ProPanel has saved views. This is a time saver as well when working on your 3D panels. I did cover this briefly in the 2026, but it was a very quick presentation. You can actually save views of what you're working on, and you can choose to save them either from saving the view angle as well, or whether to save what's shown or what's hidden. The advantage of that is if you're working on a single DIN rail, you have to step away from your panel and then come back and open it up again. By clicking on it, you go straight back to where you left off without having to rearrange your view. Sometimes if you're very familiar with 3D CAD packages, it's quite quick and easy. Sometimes it can be quite frustrating to start hiding doors, hiding bits and pieces, and then getting back to that level. And then to add to all this, we now have a ProPanel wire center. The wire center, the wire manager, actually allows you to view all your routing connections like we've just made with wire routing. It also provides filters and a way of debugging and checking your wire routing. So in fact, it's a toolkit, tableized toolkit that appears at the bottom of your window, your 3D window, and allows you to quickly and easily navigate all your wire routing, see what's routed, see what's not, see what you're missing, and debug and fix any problems you might have. All right, before we get to the copper bending, I'll just run you through a few of those features. Primarily the cross references. So if I was to go back to that power supply here, obviously this project in my paper space, I have not just the schematics, I have 2D layouts. I have the 2D internal layouts within the same project. I have the 2D panel layout navigator available to me in ProPanel. And then looking at that power supply, what you can do as a handy feature is say cross-reference function, give me a list of all the cross-references. So this shows me all the cross-references for this one device. Can be useful if you've got a cable or terminal spread off multiple pages and you can see where they're used. But what we have here, which is a new object that's included, is your model views. So by going to this, I can actually see that that power supply is displayed in this model view. Same with the next one. Go to graphic, it's displayed in here, and it's displayed in here. Yep. So that's the cross-reference to model views. Let's go back to the layout space and have a quick look at these views. What I commonly do, I mean, just part of this copper bending is whenever I open this up, I have to kind of select holding Control and Shift multi-surfaces and then hide. to be able to get access to something. If I didn't want to do that every time, I would simply go to layout space on the right hand side, layout space views. This is under the insert center and it's a new tab that's been added. I can right click and go add current view. And what that allows me to do is if I have to step away from this panel to another panel and then back, you'll see that it's put everything back on. And I don't want to have to go through that process every time. So clicking on that, I'm back to exactly where I left off. Other advantages come from if I'm viewing it just a single mounting rail, and I've got it in a point where I'm quite happy with the layout here and I just want to use this view regularly. I'll then start saving these. I've already saved a couple here, but as you can see, saved, so you can come straight to this place and then know that that strip there is visible, this strip here is visible, and go straight back to your working zone without having to manually navigate back to it every time. So it can save a lot of moving around in 3D views in space. Also very helpful if you're not totally familiar with the views in ProPanel and you're still getting used to it. Last one is the wire routing center, the wire manager, and it's up here. Part of the reason I went through wire routing first is because it's good to know the old way of how wire routing was done. But what you can do now is by opening this manager, you can quickly find routing connections. At the moment, this is all blank. But what you can do is click on a specific device and choose update, and you get all the connections for that device. What it's saying here is the number of routed connections. I've got 4 connections for a routed. I believe I can show them just by routing them again. Yep, so 4 connections routed. If I click on unrouted connections, it tells me there's 0 of them unrouted. Similarly, I can go to another device, like a breaker, and say refresh. And it tells me at the moment, routed connections, I have 0. Unrouted connections, I have 6. I have routed these previously, so they do have a length. But from here, I can click on the breaker, click on those connections, and choose to route them. And then they've moved out of unrouted to routed connections. And you can do this at any kind of level of topology in the ProPanel tree diagram here for the layout space. So what I can do is say, click on the DIN rail. I believe this will work, and it tells me all the devices on that DIN rail in that hierarchy. There's currently 10 routed connections and 36 unrouted connections. So I can just come to this, Control A, and then route. And now it's routed everything on that DIN rail, only that DIN rail, and tells me I've got 48 routed connections. None of them have failed to route. What I can do is click on a panel level and refresh as well. And that tells me in this panel I have 48 connections made, 28 unrouted connections, and same thing, I can just highlight them all and then route. And then now everything in the panel is routed. You can actually see the connections for the back of the door there as well. So that is the routing manager. Alrighty. So what we're going to get into next is copper bending. This is now free with ProPanel, same as the wire routing, it's included. I've talked to a few people about this and they said historically bending copper was almost a magician's kind of job. Copper is very expensive, so messing up the copper bending is not a great thing. Now you can do it in virtual 3D space without having to worry, and then once you've got it all 100% correct and you're happy with it, you can then get it done. This is also kind of new to us, but we've got quite a bit of it running and we're happy with how it works. So getting the copper bending working, first important thing is to get hold of your parts for your copper routing, the copper bending. On the left here, we actually have an example panel for our E-plan. This is one that comes with the install. You can open up, have a look at it yourself. But you want to import, we suggest Ritel parts because they're correctly defined with all the parts data required for the copper rails. You want to make and edit forms. Everything in copper bending is based on forms and requires a .fp1 file. You want to choose to bend the copper via the copper bending tool in the package, and then lock it into place or on a mounting bracket to actually place it in your panel. These can then be exported. You can export the bending data and busbar cutting lists as well. So for copper bending parts, obviously if you're using another supplier, no problem. You can build the copper data up yourself and have a look. It's a little bit more complex. Or you can use a Ritel part and make a copy of it, but I'd really suggest Ritel has a beautiful selection for all of this. The way I regularly go about it when I start into this is if I just jump to a blank Google and we go to Ritel, it takes us to the Ritel website. We've all seen this. I just search for E-CU, and that takes me to the bus bars. Clicking on those, it actually gives you the tree structure up here of what you're looking at. You can actually go all the way back to the rifle power systems. And then scrolling down on this page, it gives you all your possibilities. These are all the large square bus bars with their mounting brackets and everything required for that. As a starting point, we're into this bus bar flat PLS systems. Running under that, you've got your bus bars here. You've got all the possible accessories for it when it loads. But you've got mounting brackets, holders for the 3 bus bars. These are all in the data portal. They import. You can drop them straight into your panel. And it will give you a good sense of how to make equivalents. If you can make 3D macros, you can use those as well. The reason we're going to this level here is we're just going to come down here to the actual 2.4 meter lengths. And what we've got is a whole bunch of parts listed with the width of the bar and the thickness of the bar. And this is a great starting point for any copper that you're using in your panels, because you can get these parts straight from the data portal and use them, and you're away. So that's where to kind of start with the parts. Obviously, you can get the connectors, adapters, accessories. I've used a couple of these isolators, etc., straight from the website and the data portal. Next, we've got forms. Forms are almost like extrusions, where you have a red origin point and you're drawing a 2D line graphic, and you're using that graphic as its form. It's saved as a form, and like reports and plot frame forms, you can open, close, or copy, meaning that you've got that full structure there to create a copy of an existing one and continue on in different versions of it. And you often require a unique form for every piece of copper bending, usually because each one of a set is a different phase and has to be made slightly differently. For assembling the copper, this is the bend the copper tool button that I was talking about. It's available here under insert. Clicking on that will bring up a dialog box where it asks you which part number you want to use from your part library. You can click on the 3 dots to open your entire part library. You choose the form that you want to use, and then you choose a bend radius. Finally, you want to choose flat bending or edgewise bending. Unfortunately, if you require a combination of both, you'll likely need to create 2 different bus bars to create one length. That's usually how it's done in real life, because most of these heavy bus bar benders are 2D layout flatbeds. And then you would just create bolt holes to bolt them together through the punch holes or the tap holes, which are the other 2 tools showing up here. Once you've got all your copper laid out, copper bus bars are actually grouped, and within a group, each one is given a specific label. But you can export a group of copper bus bars as DXFs, and that can be. You can also generate pre-made files for the NC bending machine, which are the Ritel bending machine. You can see these down the bottom here. Have a look at them online; they're great. But these take these files directly and pretty much automate the process of copper bending. So that's the next level of confidence there, but it does an amazing job. NC copper and DXF copper are the two different exports under manufacturing exports. These will now be in your ProPanel. So let's just jump in and have a look at this. I'll show you roughly how I go through the process. I've got this enclosure here. As I said, we don't want to start changing the views every time and hiding stuff. So moving this around, what we've got is I've run 3 non-copper bending bus bars across the back here, and I've run 3 taps off it. You can see as I'm mousing over these, all 3 are highlighting it because they're a bus bar group. So without holding the shift key, which selects an element of a group, if I open the group of them, they have a name. So I've called them B, it's fine. With these being A in the background. And then holding the shift key and choosing an individual one within that group, I've called it L1B. Obviously the second one would be L2B and then L3. And these are actually shaped from forms and brought down to connect to the back of this ACB where I've put in drilling patterns. So what I'm going to do is run you roughly through, we've got another ACB here on the right, Siemens one. I'm going to run you roughly through how I go about generating this. So I use the measuring tool. If you're not familiar with it, it's a great tool. I'm going to click on measuring. From the back of this bus bar, I'm going to go to the middle. And then I'm going to measure down to this top connector, upper plate in the middle. It'll snap back there like that. So that's where I'm coming from and to. If I get my orientation looking okay, I know that the largest distance here is vertically. So on the left here, my DZ is vertical. It's 735.4. I know my horizontal position from the middle of that bus bar is 141. And I know that I've got to come forward 87.1 millimeters from the bus bar to sit properly on that. I've actually done this a few times, so it takes a little bit of wrangling, but it's quite easy to redo it. So to create a form for copper bending, I've actually got a copper part. I've put a sample on the inside here. Let me just get out of the measuring tool. So I can grab the part number. It's here, 3587,000, and it is mass data. It is a 40 millimeter by 10 millimeter copper rail. So I'm going to have to take half that off, so 5 millimeter off the amount that it pokes out from that bus bar for mounting, and obviously because it curves, I'm going to bring it over these bus bars down and on top of that mounting point, so I'm going to have to come up 5 mil as well. So that's off that 87 and off the 735. So I would go to master data, and it's under master data here, copper, and I'm going to create a new one. There's a couple I was testing. That's that L1B, L2B, L3B, and then one I was experimenting with earlier. I'm going to call this L1 underscore web 10. Save. Grid 4 millimeter. I prefer a grid of 1 millimeter, but it won't really matter because what I'm going to do is use the same technique we use for E-plan drawing. So I know I've got, down the bottom here, snap to dots. I know we've got the first line is down on top of the first bus bar. My bus bars are actually 50 at the top. So I'm going to go across 0 and down 50. I'll try and speed this up a bit so we don't take too long. I'm going to come from that point. I'm going to pop in a square for a second just so you can see how I go about this. And this is going to be 30 by minus 30. That didn't really work. Let's move it over. And now I want to come out by that much. Delete square. This is the gap between the bus bars. I'm gonna come down the next bus bar, so that 0 across minus 50 down. The gap between the bus bar is 30, so across 0, down minus 30. Across L3 bus bar, which is across 0, down minus 50. And then I want the same angle again. So I'm going to grab a square and I'm going to say come across 30 and down 30. And build that up. And then through powers of subtraction from here down to here, the total length was 735 minus 5 millimeters, but I know I've got 490 going across to 0, but down 490.4. And then from there, I'm going minus 82 for the foot and going up or down 0. So you create a form like that from the origin and then close it and it saves automatically. And now I'm going to bend. So I'm going to go insert a bus bar, that part number. I'm going to choose my new form, flat bending, no problem, okay. And it instantly creates that shape. I'm then gonna move it and it's snapping to the edge of that bus bar. So I'm gonna push Control W to enter coordinates and I'll put in my offset of 141.09. Okay. And clip it on there. And if everything worked, it's coming up perfectly over those two rails, down, and sitting right on that plate where it's got to connect to. Then I would just place a bolt hole on there. That's how you create the forms. If you stuff it up, you can open up your form, edit it again, use your measuring tool to see what's missing, and recreate the copper bar. And then place it again, and obviously give it a label. Once you've got your copper created, you can click on it and go File, Export, Manufacturing, Machining, sorry. And down the bottom here, give me a DXF copper. Yep, this is just my E-plan file and my documents, copper forms, bending outputs, no problem. And go OK. 3 items were created. And if I open that up, copper bending, these were created just now. I'm opening one of those. This is one of the 3 ones. But you can see here it's got the 3 drill holes. And it tells you move up 45 degrees with a radius of 5 millimeters. So that's a manufacturing files it creates for every piece of copper. And that is the copper bending. Finally, just a quick note on the smart production. There's now a smart production suite available, smart production seat available with every ProPanel. What this means is you get access to smart mounting, smart wiring, and the whole smart suite. The advantages of that is once you've uploaded your smart production collection file that you generate from ProPanel, you can open it up. You run it as a server and you connect a web browser on your local network to it. And you can actually tick off every piece of DIN rail or trunking as you place it. You can tick off every part, every wire as you connect each side to it. You can click on a play button and it will actually zoom in on the 3D image and show you the route of the wire. So that once you've got your wire production automated, you can manually go through and place everything and ensure that every connection is made. This is a very upgraded alternative to using a highlighter on a printed out piece of schematic. We'll be doing a future webinar just on the Smart Production Suite. It also comes with an admin level, so you can actually log in as an admin, look at multiple panels being assembled at once across a factory or an OEM, and then have a look and say, okay, the total completion amount, how much DIN is placed, how much duct is placed, how many components are placed on the panel, and then what is the percentage completion of the wires and total completion. And you can track every job down to that level.